Welcome to the first example for scientific notation. So basically the main idea of scientific notation is to clean up numbers that involve a lot of zeros. So in science, sometimes you're going to be dealing with very large numbers, such as astronomical distances between planets, or stars even, and very small numbers, such as the wavelength of light, which is typically 0.00000 something when you're talking about visible light anyways. And if you don't understand that, that's okay, because that's physics, and we're just going to be dealing with the math right now. So the example we have right now is asking us to convert this number, 0.003004, from standard notation, which is how you normally see it, to scientific notation. So the first step in this is to realize that you need to find the first significant digit. And this is going to be the closest number to the decimal point when you're dealing with this decimal here. So I'm going to move the decimal over, and I'm going to see that it's 3. Okay, so I'm going to put the decimal place right after the first significant digit. Obviously, this is not what that number is equal to. There's no way 0.003004 can be equal to 3.004. But we can use a little trick. Since we know that the decimal system is a base 10 system, we can multiply it by 10 to the power of something. And when we're doing this, we're effectively moving the decimal place over. So in this case, we want our number to be smaller than 3.004. So the decimal place has to be moved to the left of this number. This number has to have the decimal place moved to the left to be equal to the other one. If that's the case, we need this to be multiplied by 10 to the negative something. This will make our base number smaller. And the way that you can determine the exponent here is just the number of times you move your decimal place. So you count 1, 2, 3. And that is your number in scientific notation.